afternoon. Yesterday we worked on CO41 about theoretical probability. So with that theoretical probability, remember, it was what should happen. So theoretically, if we flipped that coin 50 times, 25 times it would be heads, 25 times it would be tails. Theoretically, if we rolled that dice 120 times, each number should be landed on 20 times. That's the theoretical probability. Then what we did for our work was we worked on finding the experimental probability. We were doing our experiment for it. Rowan?
Is theoretical probability just divided?
Pretty much. So theoretically, you divide it up evenly. Yeah. So if you spin a spinner, it should land on each number an equal amount of times, right? Because it should favor one over the other, unless that one of the numbers is a bigger amount on the spinner than a smaller number. But you are correct. You divide it up into equal portions. So I'm not sure why there's talking. So today we're going to talk about experimental probability, working with the experiments that we did yesterday with the flipping of the coin and the rolling of the dice. So experimental probability is what actually happens. Theoretically, it should be even, right? You should see it evenly. But in actuality, is that what actually happened? So, sometimes, but not every time. Theoretically, it happens every single time. Heads, tails, heads, tails, heads, tails. Theoretically, it would happen in equal amounts of times. Experimentally, not always the case. Sometimes you go, oh, I reached it. The theoretical probability is what I got. A lot of times it's not. So let's actually break down our results from yesterday. So you need to look at what were your individual results from flipping a coin. So look back at yesterday's. How many times when you flipped your coin, how many times did you get heads and how many times did you get tails? So I'm going to say maybe for me, I flipped 26 heads and 24 tails. Theoretically, it should have been 25 and 25. You write down what you got. So look back at yesterday's, write down how many heads and how many tails you got. It should equal 50 because you should have flipped your coin 50 times. So now we need to think, what were the class results from flipping a coin 50 times? Theoretically, we should have had, what did we figure yesterday? 675 heads and 675 tails. So now here comes the part where we have to be really quiet and we all have to do the math so we can know what we actually got. I'm going to go from table to table and you're going to tell me how many heads you got. And then we're going to be adding up and making sure, seeing what number we got experimentally, not just theoretically. So we're going to do heads first. So when I say your name, you're going to tell me how many heads you got. And then everybody's going to get their calculator out and we're all going to be adding them up. I have everybody doing it because I'm not, and we want to make sure we get the correct number. So, Kaylin, how many heads?
I got 25.
Olivia.
25.
Grayson.
27.
Christian.
25.
Lauren.
21.
Say it louder.
21.
Claire.
25.
James.
22.
Madden.
25.
Lucas.
28.
Owen. Will,
22.
Matthew,
120.
Jude,
20.
Lakely,
25.
Fiona,
25.
Eliana,
25.
Rowan,
22.
Emerson,
25.
Rainey, Addie,
23.
Adeza,
30.
Henry,
24.
Kyle,
45.
Gabe,
31.
Grace,
28.
Elsa.
26.
Is there anybody who's absent today that was here yesterday? Asher was not here yesterday. Dominic. So I'm gonna put in my score for Dominic's. So,
I can do mine.
oh, you hadn't done it.
Yeah, I know.
I'm gonna put in my score for Dominic, so 26 heads. So add up all of those scores. What was that?
Let's put 2 pluses. 3,922.
That is not correct.
I know. I got
So I had somebody get 671. What did you get, Grayson?
syntax error.
641.
I got 641.
Oh my goodness.
I got 667.
Okay, so I have got a lot of people getting totally different numbers. So now I'm going to add them up. Re-add it up. Okay, so we've got 25 plus 25 plus 27
Oh my gosh, so many numbers.
plus 25 plus 21 plus 25 plus 22 plus 25 plus 28 plus 22 plus 22 plus 27 plus 20 plus 25 plus 25 plus 25 plus 22 plus 25 plus 18 plus 23 plus 30 plus 24 plus, let me get rid of the box, 25 plus 31 plus 28 plus 26 plus 26, and I get 667. Okay, so 667. Oh, voice is off. Now we're going to do the same thing for tails.
Why don't we just take all of them?
Why would we not do that? Well, I do like doing more math, but what if somebody didn't actually roll or flip 50 times? We want to make sure we're using the results that people actually got instead of saying, oh, they should have flipped 20, so it should be 50 minus this, and we get that. It's not always the case, so we're going to go through and we're going to do tails now. Be careful with your adding up. Do it one at a time as I go through it, so we all get the same answer. So, Keelan,
25.
Olivia,
25.
Grayson,
23.
Christian,
25.
Lauren,
29.
Claire,
25.
James,
28.
Ben,
25.
Owen, 28, Lucas,
20.
Will, sorry, did you say 28?
Yeah.
Matthew,
23.
Jude,
30.
Lakely,
25.
Fiona,
25.
Eliana,
25.
Rowan,
28.
Rainey. And Emerson. Adeza. 20.
Yeah.
Patty.
27.
Henry.
26.
Kyle.
25.
Gabe.
20 or 19.
Elsa.
24.
Grace.
22.
And my result was 24. So add all of those up.
683. I got 683.
Okay.
You're a lot of 683.
Yep.
Yeah. 25.
Oh yeah, he did not say 45. So that's why use the numbers that I wrote on the board. Sometimes we hear people across the room a little differently. Yep. So 683. So hold on, friends. It says compare your results to the class results. I had more heads than tails, but the class had more tails than heads. So it flip-flopped. Okay, so were yours more heads than tails or more tails than heads, or was it equal? Our class as a whole was not equal. We were not at our theoretical probability of 675 and 675. So our second question, which was closer to theoretical probability, yours or the classes? Some of us that had the 25 and 25, you actually were at that theoretical probability. But for a lot of us, like me, I had 26 and 24. My experimental probability was not the same. So it was off. Some of us were off by a lot. We had somebody with 32 and 18. Whew, that is a big difference in that probability, right? And that happens. Every time we do it, we are not going to reach that theoretical probability. So for me, what was closer? How would I figure out 26 and 24 to 25? Is that closer, or is 667 to 675? How do I figure out what's closer? How do I actually know? Jude?
Would you do the one of the numbers minus the theoretical result?
That is a good guess, but no. Because big number and little numbers, how do we compare them? What can we do to compare them? Lucas. Finding the difference isn't going to be a good comparison because we've got really big numbers and we've got really small numbers. So finding a difference isn't a good way to compare. If I had 8 minus 6 and I have 500 and 450, how do I know which one is closer? What do you think, Claire? Not just reducing, because we might not be able to simplify anymore, but you're right, fractions plays a part. What do we do with those fractions, Grace? And what do we get from that? A percentage. So we can see what percentage it is. If it was at 50%, then we know it's the theoretical probability, right? Because it was theoretically, it was half and half, 50%. So if I have 26 out of 50, that percentage, so find out your percentage, that was 52% was heads. So I know it was 48% was tails. Let's look at what our class was. 667 out of, what was it? 1,350 altogether. So 667 divided by 1350. 49%.
But the plus is 49.
And for tails, it was 683 out of 1350. 51%. So it looked like 26 and 24, it looked like that's closer to the theoretical probability, but look at my percentages. I was 52% away, where theoretically this was only 51%. So finding that percentage helps to really see what is closer. When you're working with big numbers, there can be a bigger gap, but it's still a closer percentage. Now let's look at rolling the dice. So with my dice rolls, because I'm going to fill my numbers in for Dominic's, I had 19, 18, 17, 21, 16, and 29. So remember, theoretically, we should have gotten a 20 every time we rolled the dice. Yes?
I didn't finish it.
Why not?
Because you said to give our dice back.
Oh, I said if you were finished, return your dice. How many more do you have left to do?
I think I have like 20.
Come here, real quick. Finish real quick. By the time I get to you, you should be done. So I'm going to erase our heads and tails. We're going to do our ones first. You're going to tell me how many you roll, how many ones you rolled. No, because you gotta give us your results, Rowan. So, just like last time, you are adding up. Don't add up the numbers that you hear, add up the numbers that I write on the board, okay? So, Kaylin,
I got
we're doing just the ones to start.
32.
Olivia,
19.
Grayson,
18.
Christian,
23.
Lauren.
27.
Say it loud, Lauren.
27.
22. Claire,
15.
James,
14.
14.
Yeah.
Madden,
17.
Owen,
25.
Lucas,
15.
Will,
29.
Matthew,
20.
Jude,
Okay.
Lakely.
So I'm adding my.
I'll coming back to you. Fiona,
22.
Eliana,
21.
Rowan,
21.
Rainey,
17.
Emerson,
20.
Adeza,
23.
Addie,
22.
Henry.
How many what?
How many ones? You should have these all added up already.
23.
Kyle,
12.
12. Gabe,
14.
louder please.
14.
14. Elsa,
28.
Grace,
19.
19, and I had 19. So how many ones is that altogether?
5.
5. Oh, sorry, we have to add on Lakely's. Let's not toss pencils. 17. So add 17 onto that. 522. 542. Okay. Some of us, it's easy, we know, to make mistakes when we are adding a lot of numbers. If the majority of us got 542, that's what I'm going with. So is that correct? 542?
Yes.
Okay. Now we're going to do our twos. Kaylin.
17.
Olivia.
20.
Grayson.
25.
Christian.
25.
Lauren.
17.
Loud.
17.
Claire.
35.
James.
25.
Madden, 18.
Yeah.
Owen,
14.
Lucas,
20.
Will,
27.
Matthew,
19.
Jude.
21.
Do you have it all done now, Wakely, or are you still going? Okay. 18. Fiona,
20.
Eliana, Rowan,
17.
Emerson, Ramy, 30. Adeza,
15.
Addie,
11.
Henry,
25.
Kyle,
22.
Gabe,
20.
Elsa,
19.
Grace,
18.
and I had 18. So 17, 20, 25, 25, 17, 35, 25, 18, 14. What did we get?
554 to
557.
552.
Yeah.
550.
Raise your hand if you got 552.
Yep.
Raise your hand if you got, what did you get, James?
554.
554. What did you get, Damien?
553.
553?
Yep.
Jude, what'd you get?
534.
534? You got
527.
527. We're gonna go with, what did you have, Olivia?
552.
552, that's what most people raise their hand to? We'll go with 552. All right, on to our threes. Be ready for me when I call your name. What is your 3 number? Kaylin,
19.
Olivia,
22.
Grayson,
20.
Christian, 15.
Yeah.
Lauren,
24.
Claire,
20.
James,
16.
Madden,
19.
Owen.
7.
I'm sorry, did you say 7?
Yeah.
Wow, that was a low one. Lucas,
20.
Will,
16.
Matthew,
17.
Jude,
25.
Lakely,
25.
Fiona,
21.
Eliana, Rowan,
16.
Emerson,
20.
Ramy. That was a 16. Adeza,
26.
Addie,
27.
Henry,
16.
Kyle,
18.
Gabe.
18.
What was that, Gabe?
18.
Elsa,
23.
Grace,
22.
22.
Yeah.
And I got 17.
521.
521.
521.
Last time I got 503.
Yeah, you must have missed adding one. Okay, now we have 4s, then 5s, then 6s. 4s, Kaylin,
19.
Olivia,
24.
Grayson,
17.
Christian,
15.
Lauren,
18.
Claire,
20.
James,
17.
Madden,
17.
Owen,
16.
Lucas,
15.
Will,
18.
Matthew,
23.
Jude,
20.
Lakely,
18.
Fiona,
19.
Eliana,
25.
Rowan,
21.
Emerson,
20.
Ramy, is that 21? Adeza,
15.
16. Addie,
25,
Henry,
24,
Kyle,
36,
Gabe,
25,
Elsa,
15,
Grace,
18.
and I got 21. Did I get everybody? Oh, I wrote a lot smaller that time, apparently.
543. 543.
Raise your hand if you got 543. We're going with 543. All right, fives. Kaylin,
15.
Olivia,
19.
Grayson,
20.
Christian,
26,
Lauren,
17.
Claire,
24.
James,
22.
Madden,
28.
sorry,
28.
28. Owen,
33,
Lucas,
20.
Will,
13,
Matthew,
18.
Jude,
20,
Lakely,
21.
Fiona,
18.
Eliana,
20.
Rowan,
18,
Emerson,
20,
Ramey,
16.
Adeza,
12,
Addie,
20.
Henry,
12,
Kyle,
27,
Gabe.
4.
Did you say 4?
Yeah. 4.
Elsa,
17.
Grace,
20,
and I had 16.
16.
16,
Did I get everybody on that one? Okay. We had low numbers on that one. Sixes. Kaylin, 18. Olivia,
16.
Grayson,
20.
Christian,
16.
Lauren,
22.
22. Claire,
6.
James,
26.
Madden,
21.
Owen, Lucas,
30.
Will,
17,
Matthew,
23.
Jude,
19,
Lakely,
21.
Fiona,
20.
Eliana,
26.
Rowan,
27,
Emerson,
20.
20. Ramey,
20.
Adeza,
25.
Addie,
16,
Henry,
18.
Kyle,
5.
Gabe,
39.
Elsa,
18.
Grace,
23,
and I had 29.
540. 540.
Raise your hand if you had 562. That's the majority. Okay, so we had a really low one and then we had a really high one. We had 39. Holy cow. So our theoretical results of each should have been 540. Theoretically, we should be at 540. Some were close, some were pretty far off. So compare your results to the class results. Which is closer to theoretical probability, Matthew? Wait. So remember, we don't want to say, oh, I'm off by so many rules. We want to look at the percentage. So for me, I'm going to find the percentage for each of mine. So this was, I had 95% for my ones. For my twos, I had 90%. My threes, I had 85%. My fours, I was at 105%. Fives, I was at 80%. And sixes, I was at 145%. So now let's look at what it is. How many total rules did we have?
324, but we only got
3720 was how many rules we should have had. No, sorry, 3240.
we were 4 off. Yeah.
Okay, so we're just gonna go with the 3420. Okay, so we're gonna go with that. So 542 divided by 3420. So this was,
3240. 3240.
did I write it wrong?
Yeah, 3240.
Oh, yep, thank you for catching that. 3240. So 542 divided by 3240. So 17%. 2's at 552 over 3240 was a 17%. 52. That's what I'm curious about.
Yeah?
Oh my goodness, 542 divided by 3240 was 17%. Oh, because we're rounding. So they're both at 17 because we rounded to that 100th place. This one I had 16%. I don't think I did my percentages right up there. Those are from a different year. I'm gonna have to switch my percentages.
The mode.
I need to change my percentages.
The mode is 17%.
Yep. So 19 out of how many? 120. That's what I get for taking from a different year. So I had 16%. 15%. 14%. 18%. Can we please stop with the noises? Please stop with the noises. So my percentages were close on some of them, but I had that 24% here and this one only had 17%. So you should be looking, what percentage would it be if we actually got 20 out of 120 every time? We should be at that 17%, 16.66666. So theoretically, we should be at that 17%. So we made that theoretical percentage for 4 of them as a class. Me personally, I didn't get 17% on any of mine. So as a class, we were much closer to that theoretical probability than what I got on my own. This is going to bring us into the law of large numbers. Looking at what we discovered. Oh, stop with the noises. I am recording. This is a lesson in class. Please be respectful. What was closer to the theoretical probability? Mine or the classes? Mine or the classes? Which one got closer to that theoretical probability? The classes. Because we had so many more rules. Mine was only my 50 heads and tails, or the 120 rules. But as a class, we had a whole lot more data to put in there. So the law of large numbers tells us, do you guys need me to scroll up? Can you see it, Gabe, or should I scroll up the page?
Can you scroll up a little bit?
Yeah. So let me erase all of our oodles of data.
Wow. That's a lot of. No,
Oh, it's not wanting to erase nicely. There.
Hurts my brain.
We don't want it to be erased, actually.
All right, so law of large numbers. This is important to know. The law of large numbers tells us the more times you do something, the closer experimental probability gets to the theoretical probability. The more times you do it, the closer to that theoretical probability you get. Just my hand or coin tosses or dice rolls, I was close, but factoring in all of our coin tosses and dice rolls, we got even closer to that theoretical probability. The more data you have, the more times you do it, you get closer and closer to that theoretical probability. So now it says, use the spinner below to determine if the result is above, below, or equal to that theoretical probability. So you take 12 spins and get 4 twos. So you have to ask yourself, theoretically, if you take 12 spins, how many twos should you get? Matthew? Why would it be 3?
Because 12 divided by 4 is 3.
Yeah, it goes back to what Rowan asked at the very beginning. So theoretical probability dividing it up. Yeah, these are equal portions for the 1, 2, 3, and 4. It's divided up equally. So we need to divide our 12 spins up equally. So each time we should spin that number 4 times. We should get that number 4 times out of 12 spins. So you need to go and you're going to do the math and decide, is what we get experimentally actually above, below, or equal to that theoretical probability of getting each number 4 times. So you're going to work on that on your own. If we are watching this at home, we will talk about this more later. We are working a lot with probability in this unit, so we really need to understand the theoretical probability, what should happen, the experimental probability, what truly does happen, and that law of large numbers. The more times we do something, that closer we get to that theoretical probability. So if you're watching at home, I hope you are well. I hope to see you soon. Have a wonderful day.